Good morning again. Welcome and welcome back to the StepUP closing event. This session one will be presenting and discussing digital tools supporting the retrofitting process. Your moderator of the session is Gianluca Perillo. He's project manager at Unismart. Gianluca, the floor is yours.
Also from my side, it's a pleasure to be here. As Miguel said, my name is Gianluca Perillo. I am a project manager at Unismart, which is the foundation of the University of Padova. And in this session, we will go through the different applications of the digital tools, and we will go through the applications of these tools during the different phases of a retrofitting process. We will have 4 contributions. 4 speakers, at the end of which I will be able to direct questions to. You can ask questions below your player. You have a drop-down menu. You can select the speakers to which you want to direct your questions, and it will be my job to forward them to the selected speaker at the end of the session. Without further ado, we can move on to the first speaker. You will see the name of Amisha Panchal, but as explained earlier, the speaker will be Giulia Barbano from IES. Giulia is R&D operation manager. She has over 15 years of experience in EU-funded R&D projects, both as coordinator and technical leader. And she has worked on all scales of built environment, from sustainability of construction materials to decarbonizing networks in cities. Giulia, the floor is yours.
Many thanks. Thank you, Gianluca. So I will open the session by presenting in the lifecycle platform and the data intelligence solutions developed and utilized in StepUP. So first, as a quick introduction to this, IES, who are the coordinator of StepUP, are also our software company. We are the leading developers of the decarbonization digital twin tools, and this is what we have used in the StepUP project. So I will present to you the various functionalities that have been improved and developed through StepUP to look at digital twins, in particular for deep renovation. Now, when we talk about a life cycle platform, as I mentioned before in StepUP, we look at multiple entry points in the methodology. So we look at a set of tools used in various stages. So tools that we use in feasibility phase, of course, are very different than the tools we use in operations. So first, I will give you a high-level summary of all of these tools, and then we'll go in detail. A few of these will be presented after. So when we talk about the feasibility phase, we have 2 tools that all are accessible again through the project management portal. We have ISEM, which is in the IES ICL suite. It's a cloud software for high-level feasibility analysis of the scenarios for renovation. It can be used to analyze the renovation potential. And then we have the feasibility business case tool, developed by Energy Invest, and to compare costs and benefits of the energy conservation measures. Then in the preparation phase, we start collecting the data to look at our building in detail. So we utilize here iScan, which is a data management platform by IES, to start getting the information we need to look into the specific building performance. Then in the design phase, here we have a broader scope of tools. We have a multi-criteria analysis tools to help rank the energy conservation measure scenarios. We leverage the virtual environment by IES, the ISVE, which is utilized to carry out detailed modeling and analysis of the energy conservation measures performance. Then we have a calibration tool. This is used to ensure that the model becomes a digital twin, so it becomes an accurate live copy of the building. And we can use it to do sensitivity analysis, parametric analysis on the models. And then we have the evolution of the business case tool here in detail. So from the feasibility to the actual design phase to present the business case, make the business case for the methodology. In implementation, there's a lean tool, a lean methodology tool developed by ASR, which this will present later. And then finally, in operations phase, so after the renovation has been completed, we use again the calibration tool to recalibrate the model after the session has been carried out. We continue using the data management platform iScan throughout to keep collecting data. And we have an MMV application, so monitoring and verification in operation phase. So without further ado, let's go in detail a few of these. So the project management platform, that's the overarching entry point. So this is something that came from previous R&D project for R&D. In StepUP, it has been redesigned specifically to match the renovation methodology phases. So we have each stage, you see feasibility, preparation, design, implementation, operation. So the stages of the StepUP methodology. So for each phase in practice, what we can do is organize them in a checklist format, linking to the various tools and tasks to be carried out at each stage of the phases of the methodology. So this is an example of the implementation of the methodology in the platform for the Hungarian pilot, for example. Then, so for example, we can have links to multiple external tools. So one example was one of the dashboards. And these can be provided to anyone who has access to the project in the platform. So the CDP platform allows to manage access to multiple participants in the renovation project, different stakeholders with different permissions. So, for example, here they can access the dashboards, one that was created for the Spanish pilot. So this is information on monitoring on the indoor conditions that was provided in Spanish for the residents of the pilot building in Monasterio de Ordax. Then this is a more in-depth example of the MMV application. So this is these are insights that are carried out on the data that is in the iScan platform. So you see here on the left an example of an extract of data, and then the application carries out an analysis of the estimated energy savings against the baseline. So this is more instead of for the designers and then the operation managers. It's not user facing, but for the building operation team, for example. If we look instead at the bigger scale and how all this information is not connected, so this is an example of the feasibility study at district level. So this is in the initial phase. So this is a validated model of the BP18, the 18th district of Budapest. It's all of the public buildings owned by the municipality, validated against their actual energy consumption. So this is an accurate virtual copy of the buildings in municipality, and these have been analyzed for their relative energy consumption. So we can see the biggest energy consuming buildings, so the ones that are a better target for investment in renovation. And all the results are highly detailed and included in the platform. As you can see here, it can go down to hourly scale of data or at monthly data aggregated yearly to get a sense of, get a big picture and then zoom in on the buildings as needed. Then something that was key in the project was to make sure that we had a good data set. Yeah? So something that was developed was a data gap filling service, which was used and developed further in StepUP. So what this service does is it monitors the data coming in and then fills it in using machine learning. So it then shares a troubleshooting message through Microsoft Teams. So this is an example. It's an automated information on what happened and what were the possible causes. And so this is, for example, something that happened in the Spanish pilots. There was a small data gap of a few hours. So it was filled in over a day using previously monitored data. So the information was sent through Teams to the people who could take an action and ensure no further data losses. Then we also had a more, let's say, a more extensive look at data through fault detection. So fault detection is a very broad topic, but basically the core concept is to recognize whether there are issues in the building through the data that is coming in from monitoring. So it basically, this requires having a library that can be checked against for detecting potential faults. Now, there's many ways to do this, but specifically, a practical example here is from the Hungarian pilot. This was before renovation. So we were monitoring the CO2 concentrations in the classrooms of the kindergarten. So, and in one classroom in particular, we detected high levels when compared to guidelines like for the wellness and good air quality. So this raised an alert. And then what the service does is that it creates reports providing some information on the occurrence of the fault and correlations. Now, the correlations helped to understand what the cause of the fault was, right? So in this case, what we found that a space that's adjacent to this classroom, that is another classroom, also had ICO2 levels. So there was a possible relationship, right? So you see here that correlation between these two, which wasn't the case for the other classrooms. So the final insight was from this that the ventilation probably was not sufficient in the deeper parts of the building where these classrooms were located. So these kind of alerts then help locate these faults, understand what the possible issue is, and then also guide the interventions. So, and try and look at what kind of technological or operational interventions can be made on the building to address these. And of course, they can also be utilized to detect issues with the equipment not working properly. Now, the underpinning all of the design, then we built digital models. I mentioned this briefly. We'll see these again later. But for basically to be able to support the design and the accurate prediction of energy savings, We have built detailed digital models of the pilots. So for Zoldeget and for the virtual pilot Monastery de Artax, you can see here some screenshots. So these are 3D models that are powered by physics engine developed by IES that has a really powerful ability to model the energy demand on a very high resolution basis. So it can go down to 5 minutes, 15 minutes. Now, once the models have been built, we used data that we have collected on the energy consumption to enrich these digital models and accurately make them calibrated, so close in performance to the real thing. And then that gave us the confidence to model the energy conservation measures and know what the expected savings would be. Then zooming back in the indoors and this room level spaces. So this is for then the operations stage. For we have looked at thermal comfort, which is an important aspect. So the renovation is undertaken to keep and improve indoor comfort, right? So what we did here was improve the prediction models for thermal comfort. So this is this dashboard, which I briefly showed before. This was shown on a tablet in the Hungarian pilot. There are tablets in each classroom so that the teachers can vote on the comfort. So of course, this can be done by any user, but specifically in this case, teachers were voting on, say, on a scale from way too cold to way too hot, let's say. Now, so this is of course in Hungarian, can be customized to the various languages, etc. But the data collected could be compared with the actual room indoor environmental quality measurements at the same time. So we had on one hand teachers casting their votes and IoT sensors in rooms collecting temperature, air humidity, and so on. So these could be then used to carry out thermal comfort forecasting using a machine learning model. So we have carried out some research on different models to be used, and we have, through the project, the model has become drastically improved in accuracy. So this is an example of how the analysis can be done in the service, just a front end on this comfort service, and it can be used to check if a certain space would be comfortable with certain metrics and see, once the comfort is run, what is the expected thermal comfort in the space. Then finally, again, in operation stage, we are looking at daily heating and cooling demand prediction. So on every morning, we run a simulation of the building at 7:30. So this simulation uses forecast weather to predict the next day demand, and the data is passed on in iScan so that it is then available by the heat tank in the StepUP active system, and it's then used to control the storage in the building. So we have the accurate, so we have the digital twin that forecasts accurately the demand, and then it is used to optimize the control of the storage. And yeah, in conclusion, the software tools and the platform for data collection developed in StepUP were used to generate the sound base to continuously measure and verify the renovation. And that's all for me. Thank you.
Thanks a lot, Julia. Thanks for this very well detailed and interesting presentation. And we can now move on to the second contributor, our next speaker will be Lieven van Strellen from Energy Invest. Lieven is a senior partner and business consultant at Energy Invest. He's also the president of the board of Belesco, which is the Belgian ESCO Association. He has a strong expertise on ESCO and TPF scheme development for both public and private players. And he's also a certified MMV professional. Lieven, the floor is yours for the next 50 minutes.
Thank you very much, and good morning, everybody. So I will be sharing some insight into the Smart EPC methodology and tools that we use, as well as the integration of the StepUP approach into that Smart EPC methodology. So quickly explain, and for those who are a little bit familiar, a reminder of what Smart EPC really is. It is also an extension of the more generic EPC approach. I will dive into that a little bit to then focus on some of the tools that we have developed and are using, and show a few snapshots to finish off with some view on and thoughts about the integration that we've done between both, because StepUP is, of course, also a methodology and a step-up process for renovating buildings, and so is Smart EPC, so we had to bring them basically together. So as a reminder, what is Smart EPC really? So the EPC stands for Energy Performance Contracts, as you will also see in a minute in the more generic description. And it's really quite a comprehensive performance-based, and that's important, delivery and financing mechanism to renovate mainly public building stocks, although it can also be used for private buildings, and as such offers quite a lot of advantages compared to the more traditional approach and the classical approach, where you would work with different separate entities and suppliers, the auditors, engineering companies, entrepreneurs or contractors, and then separate maintenance companies, where nobody really provides any level of performance guarantees. In the Smart EPC approach, we integrate it all into one single type of contract with one single entity executing, which is called the Energy Service Company, ESCO. As I said, it's an evolution of that more basic model that's been around for almost 30 years, even longer in North America. And it was designed specifically for the Belgian, but also by extension for European building renovation markets. And we use a standard set of tendering principles, procedures, documents, and of course, tools and templates to go throughout the whole process, from preparation, design, implementation, and the procurement, compatible with public tendering law in those countries where it is being used. Okay. So in that sense, it's really about a tool and a mechanism, methodology to renovate buildings. If you look at the more generic approach on which Smart EPC is based, as I told you, one party is really responsible for all of the steps that you see on the right side, doing the audit, which is really an investment grade audit, choosing the measures and proposing them as part of a tendering procedure, engineering in more detailed different measures, whether it's on HVAC, whether it's on building envelope insulation. Every measure can basically be integrated. Rolling it out, of course, doing the long-term maintenance, because many of the contracts following this setup, and many of those EPC contracts are quite a long time. And of course, the follow-up and the operational phase, whereby constantly turning the buttons, basically, even more additional savings can be done. And the influence of regulation of user behavior is being controlled. And that's how ESCOs eventually can guarantee those savings levels. So that guaranteed performance, the obligation to provide a result and accept penalties if it's not reached, but also accept a bonus if performance is exceeded, is of course a key part of any energy performance contract approach. We use functional and output-driven specifications or definitions of requirements of needs, and that makes the whole process also very scalable. And that's how we can combine multiple buildings into larger clusters of buildings, and make projects also more bigger in that sense, reach ambitious goals with all of the unrenovated building stock that is lying ahead of us. It means operational risks, performance risks are being transferred from the customer to the ESCO. And so a lot of the ESCO has to do, of course, with risk management. And we can also bring this performance and, for example, the level of CO2 savings that are achieved in the heart of the competitive process. So we're not competing on price. We're not organizing this competition only on quality, but we're really bringing the performance in terms of total cost of ownership, CO2 savings in the heart of the competitive process. And that's a very big advantage. The throughput times, of course, in that sense, can become shorter. But I'll say a few words of that in a second. And we can reach economies of scales due to the clustering, but also due to aggregation. In our sector, we have designed and we've worked with so-called one-stop shops, public or public-private organizations that can basically aggregate projects and square meters of buildings from different, often internal customers in the public sector, for example, and put projects into the market for tendering that are much larger. That would have high transaction costs relatively if you would all do these separate smaller contracts. So that's also an advantage. And it's due to the functional specifications that we can scale up and not multiply basically all the transaction costs that go with it. So that's an advantage of aggregation. There are also some pitfalls. There's some things to take into consideration. It's a very different way of working, particularly people who have been doing more traditional renovations for many, many years. It does require some kind of a mindset to work in this performance-based approach. There's also a risk sometimes that that people are focusing too much on short-term gains, whereas the objective is to go for longer-term renovations and more ambitions and thus longer contracts. But because there's also the financing mechanism that provides this promise that you can get investments basically paid from the savings, then there could be a risk that people focus on the short term and say, okay, let's only do those investments that are being reimbursed by the savings. And that's, of course, not the purpose. People have to accept that intrinsically investment levels have to be high enough to reach a certain ambition level, and that you just cannot finance everything from savings. There has to be additional budgets. Another temptation, of course, is to start reintroducing input-driven technical specifications, which is also a danger. And we have to embrace, in a sense, the performance-based approach and stick to it, at least to a large extent. And then, of course, we have the ability to increase the size of projects. That can mean that the decision process as such becomes more strategic and therefore takes longer. So that's also a counterbalance that we have to find where we do have to, and we want to increase the size of projects, but we have to be careful that it doesn't complicate the whole process. Okay. Coming on the most important part, I think, of today's presentation is the tools we've developed throughout the years and still fine-tuning and sometimes completing. And I will not go in very much detail, but you see the different steps of a typical EPC or smart EPC project or program. Preparation phase, design, tendering, implementation, operational phase. And in the preparation phase, we use and we have developed tools for smart energy data collection and treatment, basically. Also getting data directly from, for example, distribution or metering companies. We have developed our own specific quick scan tools. You can see them as a simplified audit. Why a simplified audit? Because the ESCOs will do their own audit. So it doesn't make sense for us to start with an audit. We do a more quicker scan, and therefore we've developed some smart quick scan tools. Maintenance costs. In fact, most of the EPC contracts are in fact maintenance and energy performance contracts, where also the maintenance is performance-based. And we have to be able to estimate those maintenance costs because they're in the end a very important part of the whole contract and of the whole total cost of ownership. And therefore, we developed tools to simulate based on benchmarking and stuff like that, those maintenance costs. Then, and that's one of the things Miguel, my colleague, is very much responsible for, is developing smart business modeling tools. And we use them in the preparation phase, but you see that as we go further into the project, we can get more and more detailed data and get more precise business modeling tools also in the design phase. Smart EPC tendering documents, those are typical, we use two-stage procedures. So we have a selection phase and we have an award phase, a competitive phase. And those are really the specifications, performance-based functional specifications. They are in those tendering documents. Then there is a smart condition assessment. I talked about also the maintenance being performance-based. Well, we use mainly in Belgium and in Holland, for example, the Dutch standard NEN 2767. It works with condition scores. So every element is being given a condition score based on defaults that are available. And those then become the targets for the performance-based maintenance element of the contract. And if you then go a step further, and that's one of the things we pioneered, is we can then add replacement value to each of the elements. It's like an in situ value of an equipment, for example, or for any other building element. And depending on the condition score, that value, of course, will decrease as buildings are aging or as they are today. And that then gives us the rest value of investments. And that value concept of buildings, adding it all up, we've developed also specific tools which can be used in valorizing the effects of investment in the longer term at the end of contracts and so on. And then there are other elements like in the tendering itself. Of course, we designed the whole procedure. And there's also a legal motivation why we use those two-stage procedures. We use various tendering templates throughout the process, going from meeting minutes to certificates for building visits and so on. Those are really a lot of those different templates. And then, of course, when the tendering process is finished, we have the Smart EPC contract itself. Again, is a standard model that is being signed between the customer and the ESCO. Then the ESCO goes into implementation. There we use other smart project documentations for as-built files, for example, and smart acceptance procedures for temporary acceptance or final acceptance. And then, of course, very important is also the operational phase. Again, there is the ESCO is coming, of course, stepping really more into the whole project and taking over all of the operations. But still, we have the ability, for example, also to use comfort as a performance indicator, using the comfort meter methodology, which was not developed by us, but we're using it. And so we're not looking at temperature or for example, humidity or CO2 levels only. We are really looking at comfort, how it is being perceived by users. And statistically, if you have enough users, it also becomes an objective way of measuring comfort. And we can even add penalty schemes to those comfort, maintaining or even improving comfort. Smart SLA is a very important part. So the whole relationship is built around service level agreements that ESCO has to accept and perform upon. Measurement and verification. Yes, I am a certified M&V professional, but I'm not the only one. And ESCOs have them, and in each EPC project, you have quite some significant attention to the use of measurement and verification. So, of course, we follow fully the IPMVP protocol, but we also have adapted it and made some choices depending on the type of project. And then finally, reporting, follow-up again, try to standardize it, although their ESCOs, of course, have their own tools also. So this gives a summary of the type of tools we use. These are just a few snapshots, for example, of the smart SLAs, which are part of Excel-based annexes of the contract, but also then eventually operationally are being used. And we have standardized about 100 KPIs in different areas, of course, energies and maintenance, but also security or safety. Different aspects have their own predefined SLAs. Customer can choose certain, doesn't have to use them all. where we have predefined, for example, standardized penalty levels. How are those penalties being calculated? So that's where we believe, at least, that the SLAs also have become a bit smarter. And the other below, you see an example of a typical table of elements following such a condition assessment. Within the color, the different condition score for each type of element, going from level 1, very good installation, to level 6, basically has to be replaced. And those are the type of deliverables coming out of those tools. And then maybe, finishing up on some of the work we've done, because we're not doing this just on Smart EPC. We're part of the StepUP consortium, and we've worked on trying to integrate both approaches, particularly because of the need to go for deeper renovation. StepUP provides a deep renovation methodology, and this is not something we did at least a couple of years ago. Now we're also moving independently of StepUP into deeper renovations, but that was one of the challenges. And it meant that we also worked on trying to figure out how can we integrate architectural requirements, material requirements that you have when you start renovating building envelopes. Also with the StepUP mechanisms and methodologies and technology. And so we worked on defining some of those technical specifications that are not in contradiction with the performance ones, but are completing the performance based specifications. It also meant that we had to disconnect contract times from payback times, because with the deep renovation, you may end up with projects, and that's happening in practice, that are 40, 50, 60, sometimes even more, 80 years of payback time. And we're not going to do 80-year contracts. We're limited to 20, 25, maybe 30-year contracts. So we had to somehow disconnect those payback times from the duration of the contracts themselves. Then we started development of a new library of standard technical requirements linked to those building renovation measures, and predefining those requirements, because they have to end up somehow in a tendering document of a customer, and integrating also multiple benefits, because we know that because of, for example, the fact that the payback time is 60 years and the contract is 20 years, you cannot finance everything from savings. So the customer has to have motivation from other reasons to do that project, and those are what we call the multiple benefits. And it's, of course, also has to do with changing the expectations. Maintenance itself also, we have a whole methodology based on this condition scoring, but the technology used in StepUP is specific. There are maybe specific, and we identified that there were specific aging curves, for example, so that would allow us to pre-assess how those condition scores would evolve if we use some of the technology in the StepUP consortium members. And then finally, the competitive process. Our process typically in Smart EPC is we are completely agnostic of suppliers or of technology, and we let ESCOs choose what they're implementing. Of course, the purpose for StepUP partners, if they want to sell their material and their solutions, is to have some kind of a competitive advantage or create the conditions where they can be selected. And so that means that we had to kind of tweak the competitive process, making it sufficiently generic so there is no incompatibility with public tendering laws, of course, but make it sufficiently specific so that StepUP partners in future tenderings, we didn't do such tenderings, yes, with Smart EPC, but in future tenderings could use their technology, of course, in a competitive way compared to maybe other future suppliers. Voilà, that was in a snapshot what we have been doing and what we're doing with Smart EPC, and also the tools we're using and how we integrate it with StepUP.
Thanks, Lieven. Thanks a lot for your presentation. And just a quick reminder, if you have any questions at any point, you can select the speaker to which you want to ask your question from the drop-down menu below the player, and I will forward them your question at the end of the contributions. So our next speaker is Jesus Alonso, the Innovation Director from ACR. Jesus is a Master of Science in Mining Engineer, MBA and Master in Tunneling and Underground Works, as well as R&D Management. And he has more than 15 years of experience in national and international R&D projects, many of them related to energy efficiency in buildings, transport infrastructures, and the applications of new technologies to the construction sector. Jesus, the floor is yours.
Thank you, everyone, for attending this final event today. I'm very happy to have the opportunity to present to you the work carried out just in the StepUP project related to this new lean construction approach for renovation projects. This is the index of the session, starting with the objectives. And then we are going to briefly explain all the stages carried out just to define this new methodology created ad hoc to this project. Our main objective was to create an entirely new strategy for the deep renovation projects from the perspective of industrialized projects. And after that, we are going to summarize all these basic guidelines for something that is very important to us. This is an effective implementation of this strategy in a real project. Just a brief comment about what we understand that a lean construction project is. This lean construction is just a methodology. Okay, there are many definitions about lean construction, but I think this one is quite short and accurate. It's a methodology that aims to maximize value, minimizing everything that can be considered as waste. And what is waste? Waste is mainly everything that don't provide value. So taking that into account, the very first step is the complete definition of the value stream for the rehabilitation or renovation project. And after that, we need to apply this lean construction analysis just to finishing creating these PMP guidelines that are the project related. We are going to comment as well what this 5S is. It is also a methodology that is complementary to this lean construction. And finally, we are going to give you some comments about the digital tools we had to develop in order to be able to apply this methodology in an effective way in a real world site. So let's get started with this value stream definition. So this was the very first task to do. We defined the entire value stream of a deep renovation project. And the first innovative thing was that this analysis not only comprised the execution, the construction process, but also includes all the processes down and upstream, from the design, manufacture of the different elements, logistics, but also including operation, maintenance, etc. That means covering the whole value stream. As you can imagine, this process implied lots of communication, collaboration among stakeholders that they don't usually talk each other in the concept of a project. So the final result was this, okay, I know is this path about all the elements, all the requests, all the barriers, everything that was taken into account to define this value chain stream. So after identifying all the activities, actions, interactions among all the process, among all the stakeholders, we classify these general activities and just to obtain this stream value analysis. We are not going to describe every single activity that we have defined or identified, but it's important to remark that this is the starting point for the lean construction analysis. What we really do just to ensure that we are adding value, erasing all the waste. And that's what the second part of the analysis, this lean construction analysis. So for each main activity of the sequence previously identified, we have applied this 6 steps method. The very first step is think about it. It could be something quite stupid, if you want to call it, but it's important to think about it. In the construction sector, we usually do the same thing all the time because it was always done the same way. So nobody stops and let's think about it. Just think about this action, this activity, if it provides value or not. After that, the second step is define duration of every single activity. The third, list the sequence of actions, but it's not just listing of the actions or activities. It's more than that. It's analyzing the activities, actions, subactions, and that is very related to the fourth step, that is set interactions between every activity, every action. Once you have all of this, then it's time for the fifth step that, in my opinion, is the most important one: waste identification. Why? Because coming back to the first step, this waste identification is usually when what we don't do it because things are done the same way for ages. So is the moment to analyze if something must be done, which value provides, or if we erase that action or activity, the consequences of that action. So after this waste identification, then we are going to talk about it in the next slide. The last step of the sequence is waste elimination. I mean, once you decide interaction, action, or activity doesn't provide any value, is considered as waste, you have to erase it from this sequence. So this is a workflow about the way we are going to carry out this analysis. I commented this 6-step analysis. So the very first question, does it add value? If the answer is no, we can consider that action or activity as waste. If the answer is yes, we continue with the process, how much time is required, which is the sequence of specific actions to perform. We list those actions. Then we also in this stage we also ask, does it add value? If the answer is no, we have waste again. If the answer is yes, we continue with the process until this final part, that is look for waste. And in this case, we must be very honest. Is the current action planning, promoting overproduction? I'm not going to list all of them, but this part is very important. When you really, in a objective way, identify if something provides value or not. If it provides value, it remains in the sequence. If not, that's part of waste elimination about that particular activity. 5S. So 5S is a method. It's a Japanese, invented by Japanese developed in the 20th century by Toyota, that consists in ensure order, cleanliness of all the processes, just to improve the productivity, and is based on 5 simple principles. It's called 5S by the names in Japanese. My Japanese is a bit rusty, so I don't know if I want to pronounce it in a proper way. But what is important to remark is this 5S method is absolutely complementary to this lean construction approach. In fact, it's recommended to use both at the same time. One is focused on value, and the second is more operative. This 5Fs is more operative, that because it's focused on order, cleanliness, as you can see, according to these 5 simple principles. The first one, SAID, identifying and eliminating everything that is not necessary. It's also related to the lean approach. The second one, SATON, every item and everything is in its place. SEISO, all sources of dirt are identified and eliminated. Siketsu, well, in these cases, we are always aware just to detect anomalous situations or everything that can be a disruption for the process. And the final one, Shitsuke, is the action of making habits, just to ensure the 4 previous S are going to be implemented in our work site. Obviously, all these methodologies are needed to be implemented in a real work site. So digital tools, development of digital tools is something mandatory for an effective implementation in a real work site. For this reason, we have developed a platform that is based on 3 main pillars. It's a dashboard where you can check everything, when you can control the performance of the execution process. The second pillar is a mobile app, just to collect data in real time on site. And the third one is a database in the cloud. Okay, all this development was carried out in the context of the project, taking into account we identify this need to have something to not only to collect data, but also to control and to show the results in a real world site. This is a screenshot of the dashboard and the app. You can control all activities at the same time, but just to have clear, I just selected one of these activities. There are just, it's very useful to identify deviations, to compare the real performance of a specific activity compared with the initial planification, what is reported, what is missing. And it's also very useful to try to predict future deviation. In this case, if you see here, there is a line that represents what was planned at the beginning of the project, and then what is already reported. Joining the dots, you can get the tendency. Comparing the plan line with this tendency, you can predict the future deviations and take measures that to avoid this deviation that is obviously this is something we need to erase from our work sites. We also included a screenshot of the app just to collect data on site in a simple way. Conclusions. Okay, what we got from this work carried out in this lean construction strategy. Well, the first is we have a clear conceptual outcome. We have defined some key bases and the strategy just to change the paradigm in a renovation project. That's very important because lean construction was applied for new developments, but there was no specific strategies or methodologies for applying lean construction on renovation projects. So this is the first outcome of the project. From this specific strategy, we have defined some guidelines to implement in an effective way all these principles in a real world site. And that's also very important because you need to the strategy is good, as good as you can implement it in a real world site. And finally, we have developed these IT tools just to help everyone to not only to control the works, but also to analyze and to collect data, to analyze it in order to see tendencies and to predict the final result of the work site. And this is the last slide, is what we call the Decalogue about applying lean construction in a renovation project. This figure summarizes perfectly what everything we have done here. I'm not going to read them all, but if you follow these easy 10 steps, you can say you are applying lean construction in a real project. So thank you very much, and I hope it was interesting, this presentation.
Thanks, Jesus. It sure was. Thanks a lot for your presentation. And we can now move on to the next and final speaker for this session. Our next speaker will be David Masip Vila. He is a PhD candidate at the Universitat Politècnica de Catalunya. He is an architect and, as I said, researched the Department of Architecture and Technology at UPC. And he has been involved in numerous projects with a high degree of innovation and sustainability for more than 5 years now. He has also combined his professional career with teaching at the UIC School of Architecture and at La Salle. David, please, the floor is yours.
Thank you, Gianluca. Thank you. Well, I think you already introduced myself really well, so I'm not going to give anything else or explain anything else about myself. Just I wanted to mention that the presentation I will
David, could you please put the microphone a bit closer because we can't hear you perfectly.
Sorry. Now better?
Yeah, definitely. Thank you.
Sorry. So the presentation I will explain today, it's called Set-Based Design Matrix for a Multifunctional Plug-and-Play Facade. I wanted to mention that this research has been done in the frame of the StepUP project. And also I've been doing this research with two of my colleagues, Grazia Marrone from the Politecnico de Milano, and Irene Raffles from Eureka in this case. Just a bit an explanation of what I will explain today. I will explain first a couple of concepts, define what is multifunctionality, what is a design-based matrix, and also what is complete. In this case, also a bit brief introduction of what is prototyping, protocol that has been used, and then I will go through the presentation, the topic of today, which is the methodology. So let me start defining the concepts. I think it's important that everyone is on the same page. So let's start defining what is a set-based design matrix. Now, in this case, it's a tool used in engineering and product development to facilitate decision making during the design process. So basically, it helps teams explore and evaluate various design alternatives before arriving to the final solution. So this is important in the StepUP project frame, let's say, because here we have been developing technologies for the decarbonization, for deep renovation of the building stock. And before all these technologies are arriving in the market, they need really strong background or strong development behind, right? So this is why we developed this design matrix. Also, what do we mean with functionality? No, a functional state. So in this case, one of the main outcomes of the project was to develop a system with different functionality. Okay? So what means different functionality? So it means that the system offers different complements or different elements that not only being a thermal solution or a facade for thermal solution. So we are trying to give them more options like windows, giving them blinds, also energy production, or also include the active systems on the facade in the same component. And then the plug and play facade, it's a top like a term that you will be hearing for the whole presentation today, and we will be explaining in more detail by Marta Lupi in the session 2. But I just give you highlight, okay? Like what is a plug and play facade in this case? We refer to a building facade system that is the fabricated offer. It's designed.
Sorry, David. Just
yeah.
Try to keep the microphone close, so
okay.
Because when you have it further away, we can't hear you very well. If you keep it close, it's better.
Okay, okay.
Sorry to interrupt.
I apologize for that. So I was saying that the prefabricated system is the plug and play. What I'm referring, it's meant to be designed for easy installation and easy, and also installed in the existing structure of the building. So once we saw all the concepts that are related with the presentation, I will go through the prototyping. So I'm not gonna explain a lot what is prototyping and what is the knowledge level behind. But the thing is, prototyping at the end is trying to provide a design that works for the end user. Okay, so it's really common to use this classification, which is the real classification made by NASA, and also gives or specify the different levels of the prototype. So it's pretty clear that there's the first levels are in the design phase, then levels that are more in applied research or more the technology validated in a real environment, and then also in a real construction or in a real pilot. So once it's set up, the prototyping at the end is to be sure that everything is working again, or to test different steps. I wanted to also include or to mention the plug and play protocol that has been developed. So all the technologies that has been developed in the frame of the StepUP project has been thought under these 6 main principles. Let's start with industrialization. It's one of the main topics that also it's included or it's implicit in the concept of plug and play in this case. But what we were trying to achieve, it was a system which was prefabricated offsite and it was a really low intensity. Then we were trying to find a product or a technology that has been compatible with a really high degree of different geometries or also different aesthetics. So this is why optimization was important, and also compatible and interoperable with other technologies in this case. No, and this is why we were talking about multifunctionality in this case, no, because the systems that we are thinking have to be compatible with other technologies. Then 3 concepts that are also really important is the circularity. In this case, we are trying to provide technologies that has a really low impact in terms of embodied energy, and also trying, as Gail explained before, using lean philosophy concepts and also design. And then the open exchange information is also quite important, even if it can seem banal, because it's one of the aspects that gives more value to the whole design phase. If all the parties involved in the design phase are providing a high level of information of the product, then the design of this kind of systems is more accurate. Okay? And then the regulation topic is something that I will see, but it's not less important. Okay. So what we did in the project, or at least in this design set methodology, is to define 8 main steps that has to be fulfilled for a proper design for a multifunctional plug-and-play facility, right? So now I'm not going to read it, but I will go through now slide by slide, explaining it a bit. Just wanted to mention that from the step 5 from the step 8, it will be explained in more detail in the session 2 by Irene Rapport in the presentation third-party products integration. But I will give you a brief introduction of all these things, okay? So starting from the beginning, what is really important in this case is trying to understand the system that we are going to install, or the system that we are going to study in this case, right? So in the StepUP project, plug-and-play technology has been developed, one from a facade system, and the other from an active system in this case. But this presentation is only focused on the facade system. So in this case, we focus on the section, the cross section of the system, right? So we started identifying the main layers of the system. In this case, it has been divided in 5 main layers. One, the external layer, then we have the air gap in between the external layer and the insulation in this case. And we had the third layer, which was an insulation, and also the structural part of the system. We had another one, which was an air gap in between the insulation and the existing building. And then we have the 5th layer, which is the existing envelope, and also the structure of the whole building, mainly. So once we define these 5 layers, it's important to think about which kind of products can be integrated on the facade system to give more multifunctionality in this case. So we started drawing the products on two main groups, let's say. One, the ones that affect the passive systems of the facade, and the other one that can be affect the active systems of the building, and also the energy product. Let me mention that I will probably be repeating the word TPP in this case, which means third-party products. It's what I'm showing in the slide right now, okay? So then if we're going through the passive system, we have the external layer. Here what we were trying to achieve is giving more options or customizability, like offering more options of customization to the final end user. Different surface finishes, different colors, different sizes, different geometries. And then also that to include a window with high performance in the panel, also sound protection, ozone sharing in this case. And talking about active systems, then we have integration of the panels, heating and cooling systems, and then also the demand control ventilation in this case. So then the third step of the step-based methodology is the identification of possible scenarios. Here, what we have to do is thinking of the 5 main layers that we done in the first step, and also the components that can be integrated. See which kind of scenarios or third-party code can be integrated in each layer, and then be realistic. So, for example, in the case of the integration of a window, then we will never integrate a window offside of the thermal envelope in this case, no? For example, the layer 1. So this scenario will be discussed. So this is what more or less has to be done in this study to understand which kind of scenarios will be realistic at the end. Okay, and then once we already understand which kind of scenarios we got, we go through the demonstration in a real environment. In this case, we work in a 3D software, trying to integrate the components inside of the model and trying to verify if it was making sense or not to include this prototype, right? Here I can show you a couple of a brief example of what is the integration, for example, of a bleed on this kind of system, right? So, for example, it can be one scenario which is included in the layer 2 in this case, but then the other scenario, the layer where the photo revenue is included in the third one, in the isolation part, which means that also the components that are associated And also here we thought another scenario in the virtual environment, which was including the foldable link into the thermal envelope in this case, right? But this scenario has been discovered because at the end, once we made the integration in the virtual environment, we detected that it was not following all the principles developed in the thermal process, because then the system was not able to be disassembled in this case. And also, it was not really feasible to build, to install the product, right? And then the fifth step is to develop the technical design alternative for each scenario. So it means that if we decide to go through these two scenarios, which are the ones that we already detect in a real environment that we're looking, so we are going through to define the technical alternative for it. So how we do this? We develop this matrix to understand and to help also to understand which kind of requirements we will find once the product is already installed, right? So the table is quite useful, starting from here, from the first arrow, selecting the third-party product that will be installed. In this case, we're talking about it. Okay, so we have one scenario and two scenarios. Let's start one scenario and two scenarios in this case. And then the second one is the layers that I explained in the first step. So the layers that are on the system, in this case, in the plug and play model, right? So where will be the third-party product installed? So we're talking about the buildings. It will be included in the first scenario in the third layer, which is the standard sandwich panel, which is the scenario one, right? And then also, if we're going to scenario two, it will be including the plinth in this case in the layer 4. So we get different scenarios, but in this case we have to start detecting layer by layer which kind of requirements are giving us the fact of installing this third-party product in the layer, right? So this is more or less what we show here. It will be more detailed and also more explained in the presentation, and you will see also the examples. But also, what is important here, and because we are developing technologies for buildings, and there's like really huge scale involved in the project, the seventh step is the demonstration for the prototype. Here, we encourage everyone to work in 3 levels of prototyping. In this case, working in a preliminary prototype, which is done on a scale, which is mainly working on a laboratory, in this case, or in the facilities of the companies are interested to collaborate. Then the second level is working in a mock-up, for example, implementing the technologies in a scenario which is mainly similar to a real scenario. And then the third level of prototyping is in a real case scenario to validate the technology and also the system that has been thought. And then the last but not the least, but in this case, is the validation phase, where there's so these kind of systems, even if it's a complex system, it needs a couple of tests to validate that the system is working. So now I'm about to finish my presentation, but I just wanted to thank you all and mention that I put here a QR code, and if you are interested to have more information about the design set-based design matrix that we developed, you can find the paper here, what has been published in PhD. And also I want to thank Gracia, Marlena, and Irene for the contribution in the work. So thank you from my side. And I will give you time now for questions and answers in this case. Thank you.
Thanks, David. Thanks a lot for your presentation. And thanks to all the speakers who intervened for this session. We have 5 minutes for a couple of questions that I have here. I will start with one for Julia. And a question is, who are the users of the software solutions that you presented? And connected to that, if do you already have feedback gathered from these users?
Yeah, thank you, Gianluca. So the users for the software solution are varied depending on the phase of the methodology you're in. Some cases you're working more with the owners, or in some cases the occupants of the building, but in other cases it's more technical users, so like the energy consultants, the architects, and so on. And yeah, we have gotten some feedback. We have worked with the users as part of the project, as like, for example, when we're testing the dashboard in the pilots with the comfort collection, but also like on the models, on the feasibility modeling analysis, we've been working with the municipality as the end user. So we could leverage the vast variety of stakeholders that are involved in the project to test the solutions with them. Yeah.
Thank you, Julia. I will have a question now for Jesus. And the question is, which are the main barriers to implement the lean strategy you presented in a real project?
Yeah, probably it's a stereotype or a topic, but this resistance about it, because the very first step is to analyze what you are doing right now in order to identify what is waste and what adds value. It's difficult to achieve in these meetings with all your suppliers, contractors, to create this analysis from an objective way. If you are doing the same thing for 25 years, for instance, and then you are in a meeting and someone asks you to think about the process you are carrying out and commenting that probably that action or that specific activity should be raised, that provokes some barriers in the mindset of everyone that is participating in that meeting. But this is, but the way to solve this problem is communication, training, explaining why you are doing that everyone can get benefits from this strategy. And after meeting, we can say we're achieving this objective. Our subcontractors and suppliers now are open to rethink everything in order to optimize the whole process, taking into account that now the project itself is, they can see the project as a whole, not just a sequence of activities that I'm responsible just for the first one, and this is everything I have to have in mind. No, this work about training mainly and communication works. We can say that after these years using this technology.
Thank you, Jesus. And we have time for one final question, and this is to Lieven. So the question is, what would be the role of engineering companies, contractors, and suppliers in the ESCO beyond the StepUP project? You're muted, Lieven.
Yes, that's right. Sorry for that. I think engineering companies can play a double role. They could become facilitators or work for one-stop shops that are doing project facilitation. Because in such facilitation, there's also a need for quite some auditing knowledge, engineering knowledge. So that's one possibility. But they can, of course, also be part of an ESCO consortium or work as a subcontractor for ESCOs in the design of measures and then the implementation of them. Contractors themselves, of course, could turn themselves into energy service companies and delivering energy performance contracts or smart EPC contracts. But of course, that's not something that you invent, and it's a new way of working, and it's quite a challenge. They have to put risk management into the core of their activities. But to the extent that they already are familiar with renovation processes and doing building renovations, that could be an option. Or they could work again as subcontractors to ESCOs, larger ESCOs that need, and that will in any case often outsource different parts of the whole renovation process. And different subcontractors, yeah, they can work, of course, for ESCOs themselves. Could be, for example, a maintenance company, and we often see consortia where you have a typical building contractor working together with a maintenance company, because both components are in such contracts. And then they would work probably, if they're big enough, they could work as a consortium partner. If they're smaller, they would probably work as a subcontractor to such ESCOs.
Thank you, Lieven, and thank you to all the speakers. We're now heading to the coffee break. We'll have a break until 12:15, and we will resume with the next session focused on the plug-and-play technologies, which will be moderated by José Sevillano from Eurecat. Thanks for being here, and see you soon in a bit.